Hello everyone. So this lecture we are going to learn about how to determine the height of a tree. So let us take one example and I'll explain you step by step. So suppose we have one binary search tree. You can take binary search tree or a binary tree, anything. So if we have this tree, so to determine the height of a tree, the entire tree, that means we need to find the height of root. So that means height of tree that is equal to height of root. Now for finding the height of root, the formula is that height of root is equal to max of height of left subtree and height of right subtree. This one. So that means for finding the height of root, you need to find, this is like here you have, this is left subtree and here this is your right subtree. So first you need to find the height of left subtree and the height of a right subtree. Then whatever is maximum of that, you need to add 1 to that, and that's how you can find the height of a root, right? So for that, again, we need to find the height of a left subtree and height of a right subtree, right? So here we need to use recursion, right? So is you need to understand, if you're not making the algorithm, then also for your understanding, you need to understand that the height of null tree, that means you have a null tree, that is equal to -1, right? Now this depends on the convention, which convention you are using. Many people use a convention where they consider the height of a null tree as a 0, right? So ultimately it depends on which convention you are using. Here what I am using, that height of a null tree, that is -1, right? And if height of a null tree is -1, that means I can consider that height of leaf node would be 0. Why? Because -1 plus 1, that's a 0, right? So this is the concept we are having. And then we can consider this like for a calculation purpose, if you directly want the calculation, right? So for a calculation purpose, you can have this like height of leaf node. So here 39 is a leaf node, so it's having the height 0. 54 is also a leaf node, it's having height 0. 80 is a leaf node that's having height 0, right? Now, if you want to consider the height of a 78, so height of left subtree, here in this case, the left subtree is this, right? So height of left subtree is 0. Height of right subtree, that is also 0, right? So max of 0, 0 plus 1, this is height of 78, right? So 0, 0, that's a 0 plus 1. So height of 78 is 1, right? Here 39 is a leaf node, right? So its height is 0, right? Now if I need to consider, if I need to calculate height of 45, right? So that's a max of height of 39, comma, like height of 8 plus 1. So height of 39 is what? That's a 0. Height of 70 is 1, 78 is what? That's a 1, right? And you need to find max of it plus 1. So 0, 1, max is 1 plus 1. So 2. Here you are getting the height of 45. That's a 2. Right. So it's a convention. Which convention you are using? If you are considering height of a null tree, it's a 0. Then this height will have a 3, right? So it based on which convention you are using, and whatever convention you are using throughout the entire concept of height and depth and this balance factor and everything, you need to consider this convention only, right? Whatever convention you are using, you need to stick to that convention only, right? So this is like how we can calculate it, right? Now, if we talk about the algorithm, right, how to create to create a program, right? So for that, we are going to use a recursion. You can do it by the iteration as well, but recursion is the good thing to opt for, right? So we are going for it. So what we can do that for consider the height of a tree. So we are using recursion. So recursion always have one base case and then a recursive case, right? So in base case, what I'm having that if my tree equal to null, right? Then in this case, I need to return -1. Why -1? Because I'm following that concept. I'm following that convention, right, of -1. So this is like, this is the concept. We need to go for the recursion case, right? This is like, this is my base case, and now I'm going to have my recursive case, right? So in a else part, what I need to do that I need to find the left height, right? And I need to find the right height, right? So I'm just setting the left height. That is, again, I'm recursively calling the same function, right? But with the different parameter, that is the left subtree of that particular node, right? And for the right side height, I'm following the same, I'm calling the same function, but with the right side, right? Right subtree. So this is, in this case, what I'm having. This is my function height, right? I'm calling the same function height over here, right? I'm calling the same one, but with the different parameters. Here the left side will go as a parameter, here the right side will go with the parameter, right? And then what I need to do is I need to return max of left height and right height plus 1. This I need to return, right? And this is like my end of if else, right? So this is a basic thing. What I'm doing here is, in this I have used the recursion, right? This is my base case, this entire path is my recursive case, right? So in a base case, what I did that if my tree is null, then it will return -1. Otherwise it will set the left height, that is height of tree of left, and right height, that is height of tree of right. And then it will return maximum of left and right, or whatever is there, plus 1, right? So in the case of example, like I'll explain you that suppose I have 54 over here and then 30 over here, then here I am having 70 and 80. Okay, so first height of a tree. So I'm going for height of 54, right? So it will go with this height of 54, what I'm finding, right? In this scenario, this if condition will not be satisfied, it will go for the else part, right? So here in this, I'm setting that left height is equal to height of trees left is what? 30, right? And right height, that is equal to height of 70, right? And it will return max of left height and right height plus 1, right? So this is what it will return. So again, this height of 30 recursively, it will go for this function only. Instead of this, it will go for 30. And if you go for 30, then again it will set the left height, right? So height trees left. What is trees left? That is null. Trees right, that is null, right? So in this scenario, it will set the left height as null for the 30. I'll show you over here that height of 30, right? So this left height would be height of null, right? And then it will go into this base case, so it will return -1, right? Similar way, right height, again, it's a height of null and it will return -1, right? So ultimately height of 30, so it will return max of -1 comma -1 plus 1, so that is -1 plus 1 0, right? So it will return the height of this 30 as 0, right? Similar way you can find for this 80, that will also 0, right? This will become 1, right? And maximum of this, so this will become 2, right? So this is a very basic thing and it's very important. So this is a way how can we find the height of a tree, right? So I hope you understood it, right? And there is a trick that also you can follow. That's not the actual method, right? But that's a trick that for a shortcut key, that if you want to find a height for your MCQs or anything, right? What you can directly do is you can find, like if you want to find a height of 54, so the furthest node, so the furthest node is 80, right? So how many numbers of edges are there, right? So that's a 1 and 2. So height of 54 is 2. That's a shortcut trick, right? Let us say one more example, that suppose we have 90, 175, right? Here we have 45. Here we have 100, right? And here we have like 125. Now, if we want to find the height of a 90, so the furthest node is this 125, right? And if we check the root, so here 1, 2, 3, right? So the height of a node is 3, right? This is not the actual method. This is just a shortcut trick, right? But the actual method is this, right? So I hope you understood it. So thank you for watching video. Thank you.